Welcome back. In this video we will show you how to deal with inequalities with asymptotes. An asymptote is an invisible line that a graph gets infinitely close to but never touches. For example, if we draw the graph of y equals 1 over x, we have a graph that looks kind of like this. You should have seen this before. That's 0. So as x gets close to 0 from either side, it gets infinitely close to 0, but it never touches the 0 line. That's because if we have x equals 0, y equals 1 over 0, and we can't divide by 0 because you'll get an undefined function. So what do we have to do with inequalities with asymptotes? Let us see an example. So if we want to solve x plus 2 over x minus 3 is less than 0. We have 0 on the right hand side, which makes things easier. So step 1 is deciding the critical values. So we would treat this like an equality. So x plus 2 over x minus 3 equals 0. So we know that when x equals minus 2, the numerator becomes 0. 0 divided by anything equals 0. So our equation is satisfied, so that's a critical point. Another point is when x equals 3. That would make the denominator 0. And we can't divide through by 0, so we know that something interesting happens at this point. So this is another critical point of ours. So these are our two critical values. This splits the graph into 3 regions. So the region where x is less than minus 2, where it's between minus 2 and 3, and then x is greater than 3. Now we take a look at all of these regions. So region 1, when x is less than minus 2, so x equals minus 5, we get 3 over 8, which is greater than 0. We need it to be less than 0, so it's not part of our solution set. So our second region was between minus 2 and 3, for example, x equals 0. So we get, if we put x equals 0 into our original equation here, we get minus 2 over 3, which is less than 0. Which is less than 0, so it is part of our solution set. Our third region was where x is greater than 3. We put x equals 5 into our original equation, get the value of 7 over 2, which is greater than 0. We need less than 0, so it's not part of a solution set. So our solution set will be region 2, when x is between minus 2 and 3. Now, we simplified that example by making the right hand side equal to 0. So for our last example, let us take away that simplification and solve x plus 16 over x plus 4 is greater than x minus 6. What can we do to make it resemble our previous example? Have a think, pause the video and come back to us. Okay, welcome back. Okay, so to make it the same as our last example, we can try and make the right hand side equal to 0. To do this, we can subtract x minus 6 from both sides. So we have x plus 16 over x plus 4 minus x minus 6 greater than 0. And then that will give us, if we simplify it, minus x squared plus 3x plus 40 over x plus 4 greater than 0. If you take a look at the notes that are written with it, they'll take you through the steps of simplification. Now, we don't want a minus sign in front of the x squared here. In general, it's not what we want. So if we multiply by minus 1, we can get rid of that. So we have x squared minus 3x minus 40 over x plus 4. Obviously, timesing 0 by minus 1 will still give us 0, but we need to remember, change the sign. So the sign will become this. So now it looks exactly like our previous example. So we will set the numerator equal to 0. So we treat this like an equality, so we get x squared minus 3x minus 40 over x plus 4 equals 0. Set the numerator equal to 0 to get our critical values. In this case, it's x equals minus 5 and x equals 8. And then set the denominator equal to 0 to get our last critical value, which would be our asymptote value. So that would be x equals minus 4 in this case. So our critical values are x equals minus 4, minus 5, and positive 8. So we have 3 regions. So x is less than minus 4, x is between minus 4 and minus 5, and sorry, we have 4 regions. X is between minus 5 and 8, and then we have x is larger than 8. So we would look at the signs in these regions and decide which ones satisfy our original equation. So you would be looking at this one here because we simplified it to be this. Here we've only used strict inequalities, so greater than or equal to. If they were less than or greater than or equal to, then you'd use them and use the same method, and at the bottom substitute in the values of your corresponding endpoints. So say if your region was this one, then you would substitute minus 4 and minus 5, see which one satisfies this equation, and then if they're included, use these ones. If they're not included, use these ones. I hope the videos have helped you understand inequalities, and make sure you have a go at the extra questions below to make sure. Join in on our chat sessions if you need more help. See you next time.